Hello students, welcome back. Let's return to section 3 and let's complete it this time. We went through the standard form of the circle, the general form of the circle, and then we went through an example problem which is more or less elementary. No problem there. Now here is a little bit harder example. Why is it harder? The equation of the circle is given, but is given in the general form, like this. If we have the standard form, then it is easy to find the center and radius. Center is h comma k and radius is r. Why? They're both coming from the distance formula. That's why. So, if we convert this general form here into the standard form there, then we're through. That's my goal. Now that's done, then we can go back to this original general equation of the circle, and then find out the intercepts using the same idea. Plug in x equal to 0 to find out y, and then plug in y equal to 0 to find out x. You see, plug in x equal to 0 and solve for y. Plug in y equal to 0 for solve for x. We can do all those. We have done many exercises regarding the intercepts, so I'm going to leave the second part to students. Let's do only the first part here. So the key is to convert this general form here into the standard form. Okay, how do you do that? This is our goal. Okay, how do we do that? Let's begin with the given general form and look at the target. We have coefficient 1 and coefficient 1 there. We have coefficients 2 and 2. So let's divide each by 2 and make the coefficients 1. So divide by 2, divide by 2, divide by 2, divide by 2, and divide by 2. Alright, do you see the equivalence between this form and that form? They are the same. Okay, so much for the trivial part. Now let's go over to some rearranging for completing the square. X squared minus 2x plus y squared plus y equals to 1, like this. Flipping this minus 1 to the other side, we get that. And then x squared minus 2x, that's one part. And y squared plus y, that's another part. And then this is a little bit different. This is this. Okay, all right. How do we work it out? Let's complete the square. X squared minus 2x plus something plus y squared plus y plus something equals to 1 plus well, here's the main idea. We're going to add something here and there, the same thing to the left-hand side and right-hand side, so that this whole thing is a complete square. What should I add? X squared minus 2x plus what is a complete square? Do you see that this is actually 2 times 1? So this is a complete square formula, so I need 1 squared here. Why am I losing color here? So that's how you can complete the square. What did I just use? I just used a plus b total quantity squared is equal to a squared plus 2ab plus b squared. So here, in place of a, I have x. In place of b, I have 1. And this 2 is part of the formula. By the way, if this is minus, then that's minus. And I should write like this, either plus or minus, either plus or minus. So that's how we get this 1 squared. Okay, how about this part? Y squared plus y plus something, but here, look at this complete square formula. I need 2. I don't have 2 here, so we'll artificially make a 2 here. Oops. And that is my b value here. So here, I'm gonna need that thing squared. Squared. Oh, never mind. Let me just write it as 1/4 here. Oops. Unnecessary space. And then that 2, just 1. And then here, let me write it as 1/4. And that's blue, isn't it? So here we have complete square. Look at the complete square formula. B is 1, and then this b squared goes here. And then here as well. Now, look at the blue part. B is 1/2. B squared is 1/2 squared, so 1/4 here. And that 2 goes here, because I have to add the same thing to both right hand side and left hand side. So from here, the second equation to the third equation, we completed square twice. Once for red and once for blue. Red was a little bit easier because we had this even coefficient to begin with. Blue was a little bit harder. We have to artificially create 2 and then a fraction, and then square of that fraction. In the end, we got what we wanted. So what we have x minus 1 total quantity squared plus y plus 1/2 total quantity squared is equal to 1 plus 1 plus 1/4, 9/4. This came from the red terms, and these came from the blue terms. And as for 9/4, conveniently, it's a square number. Most of the time, you'll have to simply take the square root, but here, we were kind of lucky. H comma k is 1 comma 1/2. Let's put some space in between. R is square root of 9/4, which happens to be 3/2. The reason we got something simple here, 3/2, is because we were extremely lucky. Most of the time, whatever you get here, and then simply take square root of that, and that's my radius, and you usually stop there. In this particular case, the radius was simple. It was 3/2. That's how you do this kind of problem. Tricky? Yes, indeed. You have to complete squares, and you have to do it twice. It's hard, but that's the way you do it. How likely is it to see this kind of thing in the exam? I'll say about 50-50 or less, because as you have written this, it's a tough problem. Let's see, what did I do here in the answer key here? Virtually the same thing. Same thing except for color coding. Visualization, let's see. Okay, this is the center. 1 comma negative 1/2. And the radius is 3/2. Okay, that's 1. Y equals 1, so it looks like it. 1.5. Wait a minute. That reminds me of nice exercise, nice technology exercise. Let's open up a web browser and let's do this with Desmos graphing calculator. Okay, here we go. Okay, all right. Okay, plot this. 2x squared, sorry about the typo, plus 2y squared minus 4x plus 2y minus 2 is equal to 0. And okay, let's zoom in a little bit. And yes, indeed, centered at 1 comma negative 1/2, and the radius is 1.5. It runs through this y equals 1 right here. How about the standard form? X minus 1 total quantity squared plus y plus 1/2 total quantity squared is equals to 9/4. We get one right on top of the other, so we ended up with blue, the second one. So remove that blue, and then we have red. Blue only, we get that. Add red. No, blue always comes second. Remove, draw, remove, draw. You can clearly see those two are identical. Remove blue, add in blue. So using technology, you can check. Okay, so much for completing the square, changing this general form into standard form. Now, do we have enough time for intercepts of this problem? Well, I don't know if I can complete the problem, but let's attempt. Okay, put x equal to 0 and so for y in this equation. So put x equal to 0, so this one drops out, and that 2 drops out, and you're going to get an equation of y alone. Plug in x equal to 0. So that's 0, that's 0. So what do we have? We have this quadratic equation. And after simplification, we have this, and that cannot be done with that cannot be done with factorization. So you have to use quadratic formula. And as you can see, it works out like this. And then if you put y equal to 0 and so for x, similarly, you'll have to use the quadratic formula again. Plug in y equal to 0. This one drops, that one drops, and what's left is this quadratic equation, simplifies like this, and then by quadratic formula, you're going to get something like this. You cannot do it with factorization, too complicated. That's one way to handle the intercepts. Another way to handle the same thing is to use the standard form you just found out. From here, plug in x equal to 0 and solve for y. So flip this one to the other side and take the square root. We get that. I don't know. To me, it's too complicated. The previous method is better. Anyway, we went through all these problems. Okay, so much for section 3, circles, and there are more problems actually. We didn't cover everything that can be covered in circles part. There are more problems. My MATLAB will be there, and some additional problems will be given through Canvas exercise set.